Oh, hey, now the microphone's on. Who can explain to me how I can solve the actual distance between Jacksonville and Orlando? And if anyone is sick at home and you missed it because the mic was off, we're going to finish 2.5, and then we're going to do all of 2.6 today. So we have a scale. Who can actually, forget it. Let's just use cards. You guys all seem like, because this is the first class of the day, you're not too raring to participate, but then when I get you going, then you're all right. So, Ellie, what is the scale on this map?
The scale is 1 inch is 110 miles.
Yeah, 1 inch is 110 miles. So I could start by setting up 1 inch. Ooh, something weird is going on here.
What?
My smartboard got way off. Sorry guys, give me a second. So try to solve that on your own. It's exactly like that example that we had done yesterday. You don't even really need to set up a proportion for that. Who can tell me why I don't need to set up a proportion? Sam?
Because you already have the unit rate.
I already have my unit rate. My conversion factor or my scale factor uses 1. And since it uses 1, that makes everything super easy. Can I help with something back there?
No.
We good?
Yesterday when Sean measured this?
No, that was for Nova Scotia. That was for the birds.
Okay.
So, if we know that every inch is 110 miles, how far is this distance on your paper? Not actually measure it, but how far does the ruler on your paper show it to be? Andrew?
Shows 1 inch and
4
something.
So, let's figure out what each of these tick marks is worth. So, if I count these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that would be 1 and 4/16, which is really, these are from yesterday, dude. That's not them. So that's really 1 1/4, or I could say 5/4 if I want to make it improper. So that's 5/4 inches, but I know that every single inch is 110 miles, so I can just take this and multiply by your scale factor, and that's miles per 1 inch actually, if I write out the whole scale factor. This is how this cancels out, because my inches on top and my inches on bottom cancel each other's units, and I get left with just miles. How many miles? If I do 5/4 times 110. Ozzy?
550?
No, it'd be 550 divided by 4.
Oh wait.
Because it's 5/4 times 110. So if it was just 110 times 1, it'd be 110. I need another 4th. So I know that another 4th is going to be 25 from the 100. And then 2.5 from the 10. So I get...
137.5.
And you gotta label that this is now in miles. Guys, on this mastery, if you don't have labels, it's wrong. Because if we're converting units and we're changing what we're talking about, you have to label your value so that it represents something. If you don't label your value, it essentially doesn't say anything. Whitney?
Do we have to label the whole thing, or can we abbreviate it?
You can, like, MI is our miles abbreviation. Be careful with the M's. MIN is minutes, MI is miles, M is just meters. So that's,
M is millimeter.
yeah, MM is millimeters. So yeah, just be careful with the M's. That's why I sometimes just write out the whole thing. So when we have a scale factor, I can use it whichever way I want to, depending on what my input is. So here, we would want the X value to be feet, so that our answer would come out in inches. So the feet on top and the feet on bottom would cancel. Here, we would want the X value to be in inches, so that it cancels out with what's on the bottom. So you can use the scale factor either way you want, depending on what you're going to input into the problem. So let's flip to the back. Monterey Bay. They are making a new sign. So they have a scale model of the new billboard. The scale model is 16 inches by 8 inches. They like printed this off the computer or something like that. They're going to blow it up into a billboard. Now they know that they're going to use a scale factor of 1 inch to 1.5 feet. So luckily, because this uses my 1 inch, this should be a little bit easier. Acadia, can you walk me through this?
So you would do, so if it's 16 inches, you would do 1.5 times 16.
Yeah, because this, I can really do times 1.5 feet over the 1 inch because that's my conversion factor. This 16, I can really write as 16 over 1. My inches on top and my inches on bottom cancel each other out, and I get left with just feet for my units. So my billboard, what will that length be? Yeah, because if I do 16 times 1.5, what's half of 16? Well, that's 8. So we add it till we get 24, and that's going to be feet. And then the height of that billboard, well, I do the same thing with my 8, just times by the 1.5 conversion factor, and that's going to give me 12. Any questions on how we did that? Because my scale factor uses the 1 inch, I can just multiply by my feet amount, or whatever the conversion amount is, with my inch values that I have. Manos?
What would you do if your scale factor was not like a 1?
So we would set up a proportional relationship like we did, I think it was yesterday. So I can do that even though this does use the 1 inch. I can solve it as if it was any other conversion factor. So we would set up 1 inch over the 1.5 feet equal to whatever we have, whether I have the feet, which will go on bottom, or the inches, which will go on top. So I have the inches. Then I'm solving for down here, so I can either ask, how do I get from my small factor to my large factor? Or this is still small to small, actually, because if I went top to bottom, that would be small to large. So that I could look at and say, well, that multiplies by 1.5, and it turns into feet. Or if I look right here, this multiplies by 16. So I'd have to do the same thing here to multiply by 16, because we know this has to be proportional. All proportions can be set up a fraction equal to a fraction.
No, but what if that like wasn't 1 inch?
It doesn't matter what this is.
Why?
So if it was 3, how do I go from 3 to 16? Well, if I don't know that, I can just do 16 divided by 3. That will give me the factor of conversion here. Like if I made this 4, well, let's say every 4 inches on whatever you're doing equals 1.5 feet. Then to go from 4 to 16 is a multiplication by 4. I'd have to do the same on the bottom. I'd end up with whatever I'm looking at would actually be 6 feet. But that's not my scale factor here, so that's not what but if it was, it works out the same way. Now, if I can't go left to right as easy as I want to, I can always cross multiply and solve that way. Julie?
Are we ever going to do paper homework?
I mean, some maybe, but you should be doing your work on paper. You have a math notebook that you should be doing your work in. So technically you are. You're just submitting things into an online system so you can get instant feedback. It's about the feedback loop. The quicker the feedback loop can happen whenever you're learning anything, the better you learn it. So it would be pointless for you to do homework and wait to get feedback. It's more effective to get instant feedback, right? So the other thing I want to remind you guys, because I've been helping people get through their homework assignments, is you can go back into the homework that you've already submitted and see which problems you got right and wrong. So please make sure you realize that. You can go to where it says like test/quiz or whatever and look at my submissions, and you can go back into it. There's a little thing that says view assessment, and you can go look at what you've submitted. So check that out before you try it again. Solve this on your own. Bet you can do it in 30 seconds.
What? Oh.
Yeah, bet you can do this in 30 seconds. I would put money on it.
How much?
A whole doll hair. If 1 inch equals half of a foot. 1 inch is half a foot. And that's 30 seconds. Elena, can you tell me how wide this actual sign is if it's 2 inches wide in the model and every inch equals half a foot?
I didn't get to finish it yet.
That's all right. Noah?
Would you do 0.5 times 3?
Ooh, yeah, so whichever I'm looking at, I can just multiply it by my conversion factor. So I could do times the 0.5 because I want to put the feet on top and my inches on bottom so that my inches will cancel out. So I could do that to either of these. So Noah said do it to the 3 first. What's half of 3? 1.5. So this comes out to be 1.5 feet, or we could say 1 foot 6 inches if we wanted. On top, if I do half of 2, it's just 1 foot. Any questions on that?
But don't you have to find the area? It says what is the
Oh, yeah. So here's the thing about finding area. Length times width, right, or whatever 2 dimensions we have. What happens when you multiply by 1? It stays the same. So when I multiply 1 by 1.5, the area just turns into 1.5 feet squared. You just got to make sure you have the right label there.
I'm still confused on how we do this on the process of it.
So regardless of what your conversion factor is, you can always set it up with your conversion factor first. So if you're still confused, you need to write this out right now. If you're out of space, get a post-it from the back table. So we start with our conversion factor. If I have inches on top and feet on bottom, my other fraction has to have inches on top and feet on bottom. So if I look at how tall the sign is, just because it's a bit more difficult, the sign has a height right now in the model of 3 inches. So that has to go on top to correspond with inches. So I can either ask myself, how do I go from the left part of my proportion to the right part, which I could see as times 3. But if that's not easy to do, we can cross multiply and solve. So let's assume that this isn't easy, and we don't know what this is. So we cross multiply and set the cross products equal to each other. So I have 3 times a half equal to my other cross multiplication, 1 times x. Sorry. 3 times a half I know is 1.5. 1 times x is just x, and I have solved for my unknown. Now, if this was something more difficult, like let's say this was a 4 instead, then this multiplication would have been 4x, and to get rid of that 4 off of my x, you know this because you always tell me how to do it. Yeah, we would just divide on both sides. So we divide by 4 to get rid of that, and then we would get our final answer. But that's if this is something other than a 1. Then we have to divide at the end. Other questions? And we're going to solve harder problems on 2-6. That's why I'm trying to get there. Dom?
What's your favorite, like...
Nope. If it's off topic, we're not taking time for it. This is the accelerated class. All right, try this. If a tennis court is 36 feet wide and a scale drawing of it is 2 1/4 inches wide, then how long is the actual tennis court? So you know its width in actual. You know its width in the model. All conversion factors compare the actual to the model or the model to the actual. Normally, they do model compared to actual. Or model above actual, like if we set it up in fraction form. So if I'm going to do the model compared to the actual, I'm going to set up 2 1/4 compared to 36. And that's inches compared to feet. I would keep your labels on since we're working with different labels. Jeremiah?
I had a question.
Yeah.
It has something to do with the accelerated class. What's the point of being in an accelerated class? Like, because when you go to college, you'll all know the exact same thing, so what's the point of having?
You will have more freedom in your high school schedule because the track you're on right now, which if you don't want to be on this track, you can change out of it, but you're going to take all of Math 7 and part of Math 8 this year, the rest of Math 8 next year, and the high school Math 1 class next year. So when you go into high school, you are going into the sophomore level math class
And will we
as a freshman.
will we be done with like math when we go to college or something?
No, so you'll be done with the high school required math a year before your peers might be. Like if they're on like the regular
So
track.
we don't have to do it afterwards.
Then you'd have choice. You'd have more elective options.
Oh.
Yeah. So then there's math classes that you can choose to take or take other classes. You could take like a STEM class or something else that interests you. Evie?
So accelerate, all that means we're moving at a faster pace than Math 7.
Yep, literally just means we're going faster.
Alright.
So we will start to speed up even more. We just needed to get through some of that like base content that's really important so then we can really start to run. Monica?
Never mind, I figured it out.
Okay. So we have bless you. We have model or scale compared to actual right now, but it's really complicated. What do I really want to do? Like if I'm going to talk about the scale used, what do most scales reference as like this compared to whatever? Monica?
I don't think I know the answer to your question, but I kind of know how you can get that.
Okay, so hang on to the process thing because we want to think about the why before we talk about the how. If I look back to all of the scales that we've, like all the easy scales that we've talked about, so like this scale, or this scale, or this scale, what do they all have in common, Jaslyn? They all reference a 1-inch amount. So what we want to do here is figure out how we get to a 1-inch amount to be able to know my scale factor. How can I turn my current inches into 1 inch?
Oh,
Jeremiah?
Division
By,
36.
is that my inches?
Oh no, 2.5. But we'd have to turn it into an improper fraction.
Ah, so I could turn this improper first and make that 9/4 inches. And you said division. What can we divide any number by and get 1 as an answer? Itself. So I want to divide by 9/4, but really, what happens when we divide by 9/4?
You can divide by 9/4
Or-
on the bottom.
What?
Divide by 9/4 on the bottom.
Yeah, but instead of actually dividing by the fraction, what would I prefer to do?
By the 1.
Keep, change, flip. So multiply with the so I can leave this as division on top because I know that's going to equal 1. But on bottom, I'm going to make this times 4/9 so that I can deal with it. Are there any questions with the setup that I've taken right now? Like why, I'm going to change that color, why I've done any of this. My goal was to get to 1 inch so I know what my scale factor is.
I have a question about whether I did this wrong or not.
Okay.
So basically what I did was, instead of changing it to 9/4, I left it as 2 1/4. So I
You just divided this like in a calculator or something?
no, I saw that there are 9 quarters in 2 1/4, and then I divided.
So you divided by 9, but you forgot to multiply by 4.
I did. Okay.
So watch how your answer varies from what we get. So, Monica, you did this 36 divided by 9. You just forgot that, the times 4 on the top. So we can actually, what Monica just pointed out, is we can cross reduce here.
Yeah.
The 9, I don't know what colors I'm holding anymore. The 9 and the 30, they're all goofed up on the tray. The 9 and the 36 can be cross reduced by 9. So this can become 4 and this can become 1. Now you don't have to do that. It just makes it easier. So now this becomes 16 over 1, which over 1 means nothing. So our scale factor is 1 inch is equal to 16 feet. Now we're not quite done. Actually, yeah, we are. Now, if this was my problem, I would then, so be ready on the test, I would then ask you to solve for the actual length. So all you would have to do is take the inches that you have and multiply by 16, because now that I have my 1 inch, I know that I can just take my number of inches and multiply by whatever that factor is, which here is 16.
5 and 1/16. Don't you have to do 5 and 1/16 as a decimal?
Yeah, but we know that 1/8 is 0.125, so we could cut that in half if we wanted.
would be 81.
I'm not certain. I'd have to grab a calculator. And is it 81?
It
Sweet.
is? It's 81 feet?
Yeah.
How did I do that?
Yeah, it is.
I completely did this backwards.
Because
I
all you
did
have to do is
16
do 5
inches
times
equal to
10,
1
which is
feet.
50, and then 5 times 6 equals 30.
That's right,
So
16
just add it.
No, 1 inch. I did this wrong and I still got the same answer.
Let's do one of these just to talk about what they.
We picked we should do Kansas.
So
It says Dorothy. Dorothy would
For
go
Dorothy.
this way.
we got to keep moving, guys.
Museum. It was really fun.
So this scale drawing that they have shown right here uses a scale of 1 centimeter equals 100 miles. That's the map. It says below, but I put it beside because I like how that setup works better. We want to make a map that uses a different scale drawing. So the first step we have to do here is figure out what's the real size of Kansas, and then figure out on our map what will be the size of Kansas. And this uses a scale factor that does not use 1. So there we go. The first thing I need to do is compute the actual miles that Kansas really is. So this 2.1 centimeters, if I look at the scale factor they used, what do I do to those centimeters?
Multiplying it
By,
by 100.
I just multiply by 100, and this becomes 210 miles, and this becomes 400 miles. So approximately, Kansas is 210 miles tall, 400 miles wide. Approximately. You guys can always look it up. I've got the Ohio map here and the scale factor and everything else.
You put it out.
I know. That's like, I hung it up so now you guys can check it out if you want. So now we have to use our scale factor, and this is where like you guys have been asking the questions like, what do we do if it's not 1? So I need you to write this work down. Even if you think you're like a rock star at this, I need you to write this work down. So we start with 2 centimeters over 125 miles. We start with our scale factor. We set that equal, because they're proportional, to whatever information I have that I'm trying to use. Now, do I right now want to use the centimeters from over here, or do I want to use the miles from over here? The miles, because I'm trying to draw a new map. So their centimeters that they used, I don't care about them anymore. Forget about them. We've already used them. We already solved it. I care about the miles. So if I want to solve for the height, I'm going to plug in a 210 down here, and I don't know my centimeters, so I'm just going to make it H. Yeah.
How do you know when to plug in the 210 on the bottom of the top? Because if you plug.
Look at the units. What units
Yeah.
does the top have?
Centimeters.
What units does the bottom have?
Miles.
That has to stay consistent.
But sometimes when we want to you put the miles in the top.
But then, if miles was on top, miles would have to be on top here. All that matters is that you match as you go across. I could set this up the completely other way. I could do 125 miles, and actually I will then. I'll do it this way for the other one. If I do 125 miles over 2 centimeters, then when I look at the width and I have my 400 miles, Mr. Cargiatis, can you quit turning around, please? I then, if it's miles, would have to put it on top. So it doesn't matter how I set it up as long as it agrees. Top's got to agree with top, bottom's got to agree with bottom. However you set up your first fraction determines how everything else gets set up. Now the problem is I didn't want to write this up here this soon because we've got a little bit of work to do over here. Can I figure out how to go from 125 to 210 really easily?
Use a calculator.
I mean, we could use a calculator, but that's not that easy. It's still going to come out to be some weird value. So I want you guys to get familiar. We cross multiply and set the cross products equal. So sorry, for the moment, I'm going to delete this because I need the space. That gives me 210 times the 2 equal to 125 times the h. Any questions on how I got this? Everybody should have this written down. This is not a I suggest. This is you need it written down.
Could I write it down as what? 210 times 2 divided by 125?
Not yet. You're skipping steps. Stop skipping steps. When I tell you write this down, write down literally what I wrote down. So then this becomes 420 equal to 125h. Still do not do the division because we do not want to skip steps. That's how we make mistakes. Now that I've done all the other math that I can, I want to get the h by itself. And to do this, what are we going to do, Sam?
Yay! You'll divide both sides by 125.
We're going to get rid of that 125 through division.
That's
on.
easy. You can just
Gosh, my smart board's screwed up.
you can just do that in your head.
Really?
You can do 420 divided by 125 in your head?
What's the answer?
Wait.
Because this is easy. Comes out to be 1. This is not.
Jeremiah. Do it. Come on, Jeremiah.
Do it or flunk.
Look, I'm not telling you to do it in your head. I know that's difficult. My height comes out to be, gosh, this is out of whack. You guys see this? It's not writing anywhere close to it. Whatever. So what's this height come out to be? We do 420 divided by 125?
3.36.
3.36. So on my map, my new map, this will be 3.36. Good Lord.
You already did that once.
I know I already did it once. Thanks.
Mr. Hudson, I was off
No,
by
if we
0.7.
watch this at home, will we see you calibrate or does it not show up?
I'm not certain.
That's why
You'll see it through that camera. I don't know if you'll see it on the screen. All right, so does that make sense? The process that we took, that we have to find the real dimensions, and then we can just scale it back to the different.
Yes.
Like our new map. Because you can make scale drawings whatever size you want. So the last thing we're going to do on these notes is take care of finding the width of the actual. So I want you guys to set up your proportion whichever way. You can set up this proportion if you want, or you could use the one that's flipped the other way. I'm going to flip it the other way just to show an example like that. So try that on your own. We'll come back together to talk about the solution. And we had already figured out that this was 400 miles. I got 6.4. Can anyone verify that?
I got it. Yep.
Does anyone have questions? Please ask them now. Yeah.
So when you're like how you did 125 feet and 2 centimeters, how do you know when to put the 400 up there, or put the or the
Like here?
Yeah.
So if I set up my fraction of the scale factor, because this is just a ratio, really. They're saying on the map or on whatever you're looking at, 2 centimeters will equal 125. So even though that says it's equal, it's really a ratio. So whether I set this up miles on top, centimeters on bottom, or the other way around doesn't matter. But what does matter is wherever I start plugging in, units have to match as you go across the top or as you go across the bottom. So my unknown value here will have to have a unit of centimeters. What I plug in on the top, because I started with miles on top, has to have miles. So if this wasn't miles, I'd have to get it to miles before I could plug it in.
So could you switch that 400 with the 210? Or no?
Yeah, if we were trying to solve this side, then yeah, I could plug in the 210 there and solve for the height as opposed to solving for the width. But up there, that last one we did, we just started with the ratio flipped. So that's why my 210 went on bottom, because miles was on bottom. Make sense?
Yeah.
Any other questions? Dom.
What did we get for the answer as the last one?
6.4. Oh, the last one 3.36, but it didn't. I did not get it captured up there.
I also the height and actual of Kansas.
Oh, you looked it up. What is it actually?
The actual length is 213 miles. The actual width is 410 miles.
So this is pretty close. 213. They just chopped off the 3, and you said 400 what?
10.
410. Yeah, so they're really close. That's what Pearson. Most of what they reference is real data, and that's what I do on my test too. I reference real data. So we gotta dive into 2.6. If you have any other questions on this, please come see me. Anyone try the 2.5 homework yet and get that done?
Yeah, me.
Yeah. What'd you think of it?
Easy.
I've tried to make it pretty straightforward. Because I'm designing the homeworks completely this year, it's kind of easier for me to know what I want you guys to be able to do.
I was like, there's someone next to
Please pass them back. Yeah, but I write problems in that program. It's got a problem editor. So like when you type things in math, you got to be able to use symbols and different things like that. So the program I use is called Problem Attic, ATTIC. Like it's an attic full of problems. It's seriously, it started as just like a repository of problems, and now it's kind of evolved into like you can export them and everything else. But then I write my own problems in there too. So especially if they have your guys' names in them, I wrote that problem. Or if it's got any Phoenix person, Estes or Cabilo, I wrote that problem. So when we look at proportional relationship problem solving, it's all of these real sort of things that we talk about. So, you're throwing your dog a birthday party. You want to set up an example of a situation that would have a proportional relationship and a situation that would not.
Why are we throwing our dog a birthday party?
Why not?
Oh, so confused.
Marley is about to turn 1 next week, and we'll have a party for her. We don't. No, because people are allergic and stuff. But we don't know exactly when her birthday is since we adopted her. But they said it was October, so we just said Halloween. You might as well. So, a proportional relationship example would be like if for every
I'll be writing this
dog,
down.
sure. I mean, you can use a different example if you want, but I'm going to have one of you guys finish this anyways. To be proportional, we could say for every dog,
Each one gets 3 treats.
each one gets 3 treats. So for every dog, we buy 3 treats.
Get 3 cakes, okay.
Which means if we had 1 dog, it'd be 3, 2 would be 6, 3 would be 9, and if we had 0 dogs, it'd be 0.
What if no one came to your dog
A
party?
not proportional relationship. Anyone have an example? Or think of something that, a situation, because remember to be not proportional, you don't have the origin point. Ozzy, we haven't really talked today.
For every 3 dogs, 7 treats.
That'd still actually be proportional.
Wait, what?
Because then you go, because still 0 dogs is 0 treats, 3 would be 7, 6 would be 14, 9 would be like, so even though in between there, they're like weird numbers, that's still proportional. Sam?
For every dog, we get 3 treats plus another treat.
So you mean every dog gets 4 treats?
No. Well, wait. Oh, dang it.
Solomon?
For every dog, you get times X a number of treats.
That's still proportional. It's like a X times the number of dogs or whatever. Julian?
No.
For every 3 dogs, you get 1 treat.
That's still proportional.
No, that's not.
So
what I
think about the examples. Think about the examples where I talked about like a bank account. You want to rephrase what you said?
meant. Yes. For every 1 dog, you get times the amount of your treats you already have. I can't say that.
Ooh, that'd be really hard to represent. I know what you're talking about, and it's not proportional, but that'd be really tough to represent. I think what you're talking about is more of like an exponential type relationship. So hang on to that one. Andrew?
For every dog, you lose 3 treats.
That'd still be proportional because it's just taken away. Whitney?
Maybe like every dog gets the amount of treats that their age is.
Ooh, that'd be a nice, interesting one. But what I really want you guys to start thinking about.
For every
Start with
You start with an initial value. So I start with 20 treats. And then buy 3 for every dog, or whatever you would want. But the way that you make this not proportional is you start with something. You don't have that 0, 0 point.
Oh, yeah, I got.
Or another situation, but this would be really, really rude, is the first 5 dogs each get 3 treats. The next 5 dogs get 2 treats, and the next 5 dogs get 1 treat each. Because that keeps changing, that would not be proportional, but that would be really mean. So I'd rather have extra treats to start with, and then 3 for every dog. But if you start with an amount, it's not proportional.
How do you do a birthday?
Hey, so notice that Jaslyn had her hand up, and I called on her, and before she could even talk, you interrupted her. So 1, look up at the class and what's going on. 2, raise your hand before you talk, man. Jaslyn.
I was going to say, I was going to say for that, for every 1 dog, there would be 0 treats. Would that be not proportional?
Yeah, if you just have like no treats. But, so if you had 0 dogs, you'd have 0 treats, right? And then if I think about graphing this, like X, Y, I just stay with 0 treats, right? So is it a straight line?
Yeah, it starts at 0.
Does it go through the origin? So the problem is it's still actually proportional. Your relationship there would be the number of treats you have is 0 times the number of dogs. Now this is a crappy relationship, but that is actually proportional. If it let me drag, well, if I could drag it over here, I would drag it over here. But that would actually still be proportional because it still has a multiplier times the number of dogs. We need something. Now, if we said we're going to buy 0 treats for every dog, but we have 20 treats for our dog, then we start at 20 and we only have 20 the whole time. Like, that's now not proportional because we start at 20. But we still have a straight line. But because we don't start at the origin, that would not be proportional. What is wrong with my smartboard today? It keeps.
It's having a bad day.
It just keeps throwing itself off of.
Tuesday. Can a relationship go into the negatives?
Do you want?
Yeah. So if for
Did it not even?
Every dog you take away like 6.
so think about for every hamburger you spend $1.
Oh, that's not expensive.
But here's the issue with whether or not it's proportional. You have to start at 0, 0. So if you started with no money and then you start spending money, you're going into debt. You can still show a proportional relationship. It would just be showing debt. If I buy 1 hamburger, I owe $1. If I buy 2, I owe $2. If I buy, like, you know what I mean? So if a map uses a scale of 1 inch to 75 feet, is that proportional?
It says
Yes.
Or 75 miles? Yeah, of course. Because this would be our scale factor. If it was 0 inches, it'd be 0 miles. Yeah, you can write there whatever you want to remember that for yourself.
Can we write
Yeah.
I wrote y'all.
The blueprint! My buddy Randy works for an architecture company. He actually works for 2 different places. One is an engineering firm. Yeah, it's the thing when you like grow up and go to college and stuff. So part of his job is drawing up blueprints for people, and you always draw them using a scale factor, because of course you can't draw them the real size. That wouldn't make sense. So, could a 6-foot long, 3-foot wide bed fit into this narrow section? I'm going to give you guys probably 90 seconds to try to solve this on your own.
You have to test it.
By the way, if you haven't noticed it,
1 inch is
scale factor's right here.
Thank you.
Mm-hmm.
Wait, which channel? Wait. Oh, okay.
Crud. So I have a question for you guys. I'm setting this up just multiplying by my scale factor. And we said we do this nice and easy because it relates to 1 inch. But if my denominator wasn't 1 inch, could I still do this?
Yes.
Yeah. I would just have a division that would then end up needing to happen. So you can use this process regardless of what your scale factor actually is. So here's the tricky part that I think is confusing some of you. Now I have inches on top and inches on bottom, but this is not a proportion. This is me converting a single value. So this is not a proportion. It's not a fraction equal to a fraction. It's a fraction multiplied by a fraction. What did you get for the length of the bedroom area? Do you have it solved yet, Manasa? Jeremiah Hahn? He's Ozzy? No. You do? You got the length?
Yeah.
What is it?
It's 7.5 feet.
7.5 feet. So the bed will fit in length. What about the width, Sean? 5 feet. Will the bed fit? Yep.
I have no clue what you just did.
What do you mean?
I lied.
I'm at 10.25.
I thought
You got 7.25?
No, I got 10.25.
Then you typed something wrong on your calculator?
Yeah.
For which did you get 10.25?
it all wrong. I feel like I did something wrong.
Yeah, let me come see your work. That's all we got for today. I will see you guys tomorrow. Try the practice. Let me know if you have any issues.